Good morning, children. Today we are going to discuss the chemical properties of alcohols and phenols. Alcohols can act as nucleophile as well as electrophile. When alcohols act as nucleophile, the OH bond is broken. When alcohols act as electrophiles, CO bond is broken, which will be discussed later. So first we are going to discuss alcohols as nucleophiles, where OH bond is broken. Now we have the mechanism to study for the alcohols acting as nucleophiles. Now we know that nucleophiles are species which are rich in electrons. So in alcohols, there are two lone pair of electrons on oxygen atom, which makes alcohol a strong nucleophile. So let's see the mechanism for the reaction of alcohols acting as nucleophiles. Here I have shown ROH, where this alcohol acting as nucleophile. ROH, where alcohols act as nucleophile, plus carbonium ion. Carbonium ions are species which are deficient in electrons, so they act as electrophile. So in presence of an electrophile, the lone pair of electron on oxygen atom will get shifted to carbon atom. As a result, a bond is formed between oxygen atom and carbon atom. ROC. A bond is formed between oxygen and carbon. We get an intermediate product from which the OH bond is shifted to oxygen atom. As a result, the positive charge on oxygen atom gets neutralized and hydrogen is removed as H plus ion. So we get the product as ROC plus H plus. So you can see in nucleophilic reactions, when alcohol acts as nucleophiles, the OH bond is broken in alcohol and we get a product. Now let's see some examples where cleavage of OH bond in alcohols take place. Examples where the cleavage of OH bond in alcohol takes place. First example is reaction with metals. Alcohols react with sodium metal. I have written examples here. Now here both alcohols as well as phenol can act as nucleophile. So here the reactions are written with alcohol as well as phenol. And similar mechanism can be written for phenol also. Now let's see the examples for alcohols and phenols where cleavage of OH bond takes place. First example is reaction with metals. Alcohol C2H5OH reacts with sodium metal to form sodium ethoxide. Here the OH bond breaks and hydrogen is removed as H2 gas and we get a product sodium ethoxide. Now next example is with phenol. Phenol plus sodium metal. OH bond in phenol breaks and we get sodium phenoxide as the product C6H5ONa plus hydrogen gas. Now the next example is a tertiary butyl alcohol CH3 thrice COH plus aluminium metal. We get OH bond is broken and we get aluminium tertiary butoxide plus hydrogen gas. So that was the first example where the cleavage of OH bond in alcohols and phenols take place. Both alcohol as well as phenol reacts with sodium metal. Alcohols react with sodium metal to give alkoxide ion, whereas phenol react with sodium metal to give phenoxide ion. Now next, reaction with alkali. Next example where the cleavage of OH bond takes place is reaction with alkali, NaOH. Example, phenol plus aqueous sodium hydroxide We get OH bond breaks and we get sodium phenoxide as the product plus H2O. Now you can see I have not written the example for alcohol with aqueous sodium hydroxide. This is because you can see that this phenol reacts with sodium hydroxide, which is a base. So we say that since phenol reacts with a base, phenol can act as an acid. And we know acid and base react to form salt plus water. It's a neutralization reaction. Now alcohols also can act as acids, but alcohols are weaker acids than phenol. So they will not react with sodium hydroxide. Only phenol will react with sodium hydroxide to give sodium phenoxide plus water. Now the next example for the cleavage of OH bond in alcohol and phenol is esterification reaction. Esterification reaction. We know how an ester is formed. Carboxylic acid plus alcohol. In presence of concentrated sulfuric acid, we get ester by removal of water molecule. That is the reaction that we have learned in lower classes. So that is our first example. Acid, carboxylic acid plus alcohol. As you can see, in alcohol, the OH bond is broken and H from alcohol and OH from carboxylic acid is removed as water, and always the esterification reactions are reversible and it takes place in presence of acid H+. And we get the product. You can see the product CH3COOCH2CH3 plus H2O. And the name of the product is, as you can see, this side we have 2 carbon atoms, 1, 2, and on this side also we have 2 carbon atoms, 1, 2. So the name of this compound is ethyl ethanoate. Ethyl ethanoate, which is an ester. This is the reaction that we have learned in lower classes. Now, the same esterification reaction can be written instead of acid. We can use anhydride, acetic anhydride. And again, third example also I have used acetic anhydride. And also we can use acid chloride, for example, acetyl chloride. So, in esterification reaction, instead of carboxylic acid, we can use acid anhydride. Example for acid anhydride is acetic anhydride or acid chloride. Example for acid chloride is acetyl chloride. Same way, instead of using alcohol, we can use phenol also for esterification reaction. Okay. Now, I am going to discuss the rest of the examples. Second example is, instead of carboxylic acid, I used acetic anhydride. The formula of acetic anhydride is CH3CO twice O plus alcohol C2H5OH. The OH bond is broken and H from alcohol and oxygen from acetic anhydride is taken out and we get the product ester. Look at the product ester, CH3CO, O, this O is from alcohol, C2H5, plus the byproduct is acetic acid, CH3COOH. Now, the next example, C, acetic anhydride plus phenol. So here instead of alcohol, I have taken phenol. In presence of H plus ion, concentrated sulfuric acid, again the OH bond in phenol is broken. So H from phenol and oxygen from acetic anhydride is removed and we get the product as C6H5OCOCH3 and this is called phenyl ethanoate. As you can see, this is our ester group COO. So the name of this compound ester is phenyl ethanoate and the byproduct formed is acetic acid. And always with acetic anhydride, one of the byproduct is acetic acid. Now the next example is, instead of carboxylic acid, we use acid chloride. An example for acid chloride is acetyl chloride, whose formula is CH3COCl plus alcohol C2H5OH in presence of pyridine base. Pyridine is a base. And remember, the reaction with acid chlorides and alcohol or phenol is not a reversible reaction. It is not a reversible reaction, it's an irreversible reaction. Now, you can see the OH bond in alcohol breaks. This hydrogen and chlorine will be removed as HCl, and the product formed is ester. Again, we have ethyl ethanoate as our product. Now, the last example is the reaction of acid chloride, acetyl chloride with phenol. The OH bond in phenol is broken and H and Cl will combine to form HCl, and we get the ester. And the name of this ester is phenyl ethanoate. Phenyl ethanoate. Phenyl ethanoate. Now, I told you the reaction of acid chloride with alcohol and phenol takes place in the presence of pyridine as catalyst, which is a base. Now, here comes a question. Why this reaction? There is a reaction of acid chloride with alcohol and phenol takes place in presence of pyridine catalyst. That is to remove the hydrochloric acid formed as a product. So, since pyridine is a base and hydrochloric acid will combine with pyridine base to form salt and water, so that the equilibrium will be shifted in forward direction and we get ester. Now, whereas the rest of the reactions, esterification reactions, that is with acid anhydride or with alcohol or with carboxylic acid, all are reversible reactions and it takes place in the presence of concentrated sulfuric acids. Now, these esterification reactions can also be called acetylation reaction. Acetylation reactions means the introduction of acetyl group into alcohols or phenols is known as acetylation reactions. Acetyl group, you know, the formula of acetyl group is CH3CO. This is acetyl group. So, introduction of CH3CO group into alcohols or phenols is known as acetylation reaction. So, we can say that the esterification reactions are all examples for acetylation reactions. That is, there is an introduction of acetyl group into alcohols and phenols by the breaking of OH bond in alcohols or phenol. Now, there is one more example for acetylation reaction written on the board. That is preparation of aspirin or acetyl salicylic acid. Aspirin is a drug, it's a medicine used as an analgesic, anti-inflammatory and antipyretic. Now, analgesic means to reduce fever. Antipyretic also means the same, for reducing fever, and anti-inflammatory to reduce the inflammations. So, aspirin is used as antipyretic, anti-inflammatory and analgesic. And aspirin, it's known as acetyl salicylic acid. So, this preparation of aspirin is also an example for acetylation reaction. For example, I've written the equation here. This is our salicylic acid. Salicylic acid. In salicylic acid means 2-hydroxybenzoic acid. We have COH and OH group. So, second position we have the OH group. So, 2-hydroxybenzoic acid plus acetic anhydride. In presence of H plus, the OH bond breaks and hydrogen is replaced by COCH3. So, you can see here OH bond breaks and COCH3 will replace hydrogen. Now, this is our aspirin. This is aspirin, or you can call this acetyl salicylic acid, and this is the byproduct acetic acid. Okay, now with this we finish the chemical properties of alcohols and phenols, where alcohols and phenols act as nucleophile in which the OH bond is broken. Thank you.